Hello and welcome to part 2 in the making a Pico game series thing that I've forgotten what I called. And in this video we are going to make a little player character for our thing that we are making that is totally planned out and in no way just being made up on the spot every time I press record. So if you remember, we got a little kind of map thing going. The first thing we're going to need to do is actually have a character that we can use. So I'm not really organising the sprites properly at the minute. Well, I'll stick the character sprites on here just so they're out of the way. And as I frequently say, I'm not an artist, so please don't judge me by what I'm about to create. But I'm going to try and make a little, I don't know, dude. Okay, there we go. We'll go with that. Some weird little dude that looks like he's from the 1800s, probably commanding a British Empire ship or something. So let's get him on the screen. So what we're going to do here is we're going to need to create a new sort of variable class to hold our player information. We will do that in here, which we're going to call init player. And then in init player, we want to declare a new variable, which we'll call, well, let's just call it player. So player, and it's going to equal a table, which is a Lua thing. It's basically an array, but you declare them differently to C#. And then we can set values in player by saying things like player.x equals, and then we'll give it a start value of, let's go with 16. Player.y equals also 16, and then we'll go back to here and we'll call that function. So player init, and that's what I called it, isn't it? Nope, I called it init player. Good start. And now we can come down here, and after we've drawn the map, because otherwise we'll be drawing the map over the top of the player, we can say spr, which is how we draw sprite. The sprite in question is number 64, and then the position is going to be player.x, player.y. If I run that, we have a little player. Oh, yeah, that's going to be a problem with the tiles and the color of the dude. Okay, there we go. It's no longer a dude, it's a woman, and she's got beautiful blue eyes. That's what we're going with anyway. So next up, we scrap this because we're going to be moving from map to map using the player. So instead, what we want to do is use this to increment the player's position. So instead of adding or taking away from the map X, we're just going to add or take away from the player X. Like we see, we've got very, very basic movement. It's not very smooth, and I really think I'm going to have to do something with those background tiles. They're very distracting. So what we'll do is we'll add another value to player dot, we'll just call it S for now, and that's going to equal 3. And that is going to be its movement. So instead of plussing and equaling 1, we're going to plus and equal dot S. And now we can change the speed that he moves here. And of course, we can also make it something like 1.7. It doesn't have to be a whole number. So I'm just going to do something with those background tiles because they are bugging the hell out of me. So we'll just make them, what should we do with them? We really don't want to be black, I think. What if we try putting a square on the outside and then making the insides black? It doesn't really look like a tile anymore, but it might have to do. Go with dark blue down this side. Dark grey up this side. You know what? Let's get rid of the tiles. I'll think about how we're going to do the background tiles better later. But for now, we've got a little character and he's moving. Not very smoothly, but he's moving. And to make the movement a bit smoother, we can delete the P off of the end of here, because what that is doing is saying that when button is pushed, it's only registering when we press the button, but it's not registering if we keep our finger on the button. Whereas now it should register, yeah, there we go. See, now it's registering every frame if the button is down. And now it feels a little bit too fast. So let's bring that down to, let's try 0.9. There we go, that feels decent. So let's make a very simple animation, and we will do that by, we'll have two values here. So player, actually let's just put a line there so we can tell them apart. Player.anim, so that's going to be the sprite that we are currently looking at. So that's going to equal 64, and then player anim count, that's going to equal 0. And then what we'll do is, and this isn't very neatly done, I'm just sort of going over the basics in this series. Maybe we'll do a better project at a later date. I still don't feel qualified to be giving proper tutorials on this yet. So then what we're going to do is every frame we're going to say player.animCount plus equals, and then let's give this another value, player.animSpeed, and it's going to plus equals player.animSpeed. anim speed. Stop putting semicolons on the end of everything. And then we want to say if player.anim count is greater than, and we're going to say 65 for now, because we're going to add one more animation frame, then player.anim count is equal to 64 it was, wasn't it? End. Which right now, of course, we've got an error because I didn't give this a value. And obviously, if we give it 0, that's not going to work. Let's just give it 1 for now. So right now, it's not going to do anything because we haven't given it another frame. But if we switch this here to player.anim, nothing happens. Sorry, this is completely wrong. So what I want to be doing here, I've completely messed this up, so let's delete that so that I can start over. So we're saying player.anim, what did I call the values? Anim count plus equals player.anim speed. And then we're saying if player.anim count is greater than 1, then player.anim plus equals 1. Then we want to say if player.anim is greater than 65 it was, because that's the value we're going for at the minute, then player.anim equals 64. We'll stick an end on there. And then finally end. Of course, we're getting an error just because I haven't put spaces there. Yeah, so as you can see, it's flashing now, and that's because it's switching between the two frames, and one of the frames is currently blank. And if we go to here and we decrease this value, it flashes faster. And what I've just realized that we didn't do is we need to, when we get to here, when anim count is greater than 1, we need to reset anim count. Right, okay, right, now the flashing, before it was flashing once a frame because it was always true after the first one. So if we go in here and we change this value to something smaller, it's going to flash slower because it's taking longer to reach 1 and change to the next animation frame. So to get rid of that horrible flashing, let's just go to our sprite, grab this, we'll copy him to the next one, paste him there, and then we'll just remove one of his legs. And there you can see he's got little floppy legs. And then we can do the same thing here, only this time we'll get rid of that leg. And then if we go into our code and we change this, no, not that, that wants to stay the same. We change this to 66. You can see he's got weird little flappy legs. So well, first off, we don't want him to animate unless we're actually moving. So let's create a bool, player.isMoving equals false. And then in here, we're going to change these all to end ifs. Okay, so now that we've got proper if brackets, well, not brackets, but we've got a proper if block, we can do other stuff in here. So what we'll do is we'll make all these else ifs. No, we can't make them else ifs because we can theoretically move in 2 directions at once. What we'll do then is we'll say, just at the end of here, we'll say player.isMoving equals true. And then we'll say if, let's just copy these, if not that and not, okay, not and not and not, then, and obviously I need to change these to the right directions. Then player.isMoving equals true. No, equals false. And then we want all of this here to only happen if we are, well, actually, you know what we could do? Since we're doing this check anyway, let's, instead of having this bool, let's just grab this and put it there. Oh, sorry, it doesn't want to be in there at all. So we want to, yeah, if we're going to put it in there, then we need to make these if they're true, not if they're false, which means we need to get rid of all these nots. And then we'll stick on the end of here, we'll just say else player.anim equals 64, which is the idle position thing. And we'll just get rid of that. And these want to be ors, not ands, because we don't want to have to wait until we're pressing all of the buttons. So now, you see he's not moving, and if we move, there we go, his little legs are going. And it's still not quite right, because we also have directions, or at least 2 directions that we're going to worry about in this video, which is left and right. So let's, instead of having this isMoving bool, let's call it flip, and it's going to equal false. So flip by default is going to be false, and false means facing to the right of the screen. So that's, by default, he's facing the direction he's facing now. If flip is true, he's going to be facing the way that he's walking at the minute. And we will do this by going up to here. And then when we're pressing left, we're going to say player.flip equals true, and then player.flip equals false. And then we implement that down here in our sprite, and there are a few variables in the sprite command that we're not using right now. So your first one is the ID of the sprite that we're going to draw. The second one is the X position of the sprite that we're drawing. The next one is the Y position. And then after that, there is, I believe, height and width, but they're normalized. So 1 and 1 would be a full-size sprite, I think. So if I made this one 0.5, yeah, it's all right. So it's not stretching it, it's cutting it off. So you're basically telling it how much of the sprite to draw. I wasn't sure if it did that or if it like squashed it down or something. So that, and then the next one is whether it is flipped or not. So the first true false value is flipped on the x-axis, so that is going to be player.flip, and then the next one is flipped on the y-axis, which is just going to be false because we're not doing that. So now if we walk around, we can see he turns, or she turns around. And let's add a little sound effecty type thing for walking. So if we go over to here, and we'll just, I can never remember which one of these sounds best for feet, but let's just try this first one. It's a bit deep. Oh, that sounds okay. So to use that, when we are actually walking, we'll do it every animation frame. So inside of this if statement, because that means we've reached the end of one animation frame, we're moving on to the next one. We can say SFX is 0, I think. There we go. There's a lot more to the SFX command, but I don't 100% understand it all yet, so I don't want to start trying to inform other people about it. So the next thing I guess we need to do is make it so she can't walk through walls like that. So we're going to do that with a collision thing, which we'll put in here. So let's just make this officially our player script, or player tab. So now if we hover over it, it'll say it's the player one. And then this one we'll just call game loop. It just makes it a little bit easier to understand what we've got going on. And then we'll call it, let's go with collide. And it's going to need to take in some values. So the values it's going to take in are, so d, oh no, we can't use dir because that's already a command. Let's just call it d. So d for direction. And then, oh yeah, that's it actually. We should be able to just get by with that for now. So the d for direction is going to be a string. So we say if d is equal to left, then end. No, actually, else if. And then we'll just copy this so we can save on a bit of typing. If d is equal to left, then do something in there. Else if d is equal to right, do something here. And then we'll copy all of this again. And then have the same for up. And finally the same for down. So now when we call this, we can pass in a direction. We can say we want you to check whether there's anything up, right, left or down. So we need some values, and basically what we're going to do is I'll try and demonstrate this by drawing. Let's just copy our little friend here, and we'll just paste her there. And if I zoom out, I should be able to just ignore these parts at the bottom. That's because it's sharing some map space with the tile map. So yeah, it's these parts here that are showing up in there. So basically what we're going to do is we are going to create a box, kind of. We're going to create 4 points like this, or 2 points, sorry. And we're going to check those 2 points, depending on where we are looking, whether it's up, left, down, right, or whatever. We're going to check those 2 points and then reference them with the map and see if the map tile that is, or the sprite that is at that position, has like a solid object. We'll get to how we're going to check if it's solid or not in a minute. But yeah, that's basically what we're doing. So the next thing we need to do is get these points. So we need 2 sets of x and y coordinates. So to get the x and y coordinates, we want a local value because this is obviously, it's just needed here. We don't need it anywhere else. And it's going to be x1 equals 0, local x2 equals 0, local y1 equals 0, and then local y2 equals 0. And now we want to set these values in here. x1 equals x, let's do it in order. y1 equals x2 equals y2 equals. And then, well, actually, let's just copy these and paste them. And also we want to end this if statement. You know what? We do need more values. We need the position of the player, obviously. So what we'll do with that is we'll just pass in the player. So if we say obj, just to say object, and then what we can do is we can just pass in the player object here, and then we can say obj.x minus 1. And then the y value is just going to equal obj.y, and then x2 is going to equal obj.x, and then this one is going to equal obj.y plus 8, and the 8 is because that's how tall the sprite is. If you were using a character controller that was 2 sprites high, you would need to change that to 16. A better way to do it would be to have the height and width of the player stashed in here, and then you could just call dot height or whatever. But for now, we're just going to stick with this, minus 1. And then for here, obj.x plus 8, that's the width, because it's 8 by 8, minus 1. Obj.y, obj.x plus 8, and then obj.y plus 8 minus 1. For up, we're doing obj.x plus 2, obj.y minus 1, obj.x plus 8 minus 3. So this is basically just trying to get somewhere near the middle of the player, because now we're checking upwards. We don't need to be to one side of the player, we need to be above the player. And then the y2 value is y plus 8 for the height minus 1. And then finally for our down one, obj.x plus 2, obj.y minus 3, obj.x plus 8 minus 3, and then finally obj.y plus 8 minus 3. Obj. Now we need to convert all of these values to a tile map position, because this is in pixels on a screen and the tile map is in sprites. So I think I mentioned this in the last video, but the tile map here, each one of these, so that this is a screen, like this whole part here, that's one screen in the game. This starts here 0, 0, and then over here is 128 and 128, and that's the pixels that we're going to be grabbing in this function. However, the tile map doesn't work like that. In the tile map, each one of these sprites is 1. So this is 0, 0, this is 16, 16, or 15, 15. So we need to round them down to compensate for that. So we'll do that by saying x1 equals floor x1 divided by 8. So we're dividing it by 8 and then flooring the result to make sure that we get a rounded number. y1 equals floor y1 divided by 8. Same for x2. And then same for y2. And then finally we get to the part where we actually do something with all this information that we've just grabbed. So we'll say if fget, and then we're saying mget, which mget is a command which will return a number on here, and the number on here is going to be the ID of the sprite. So in the case of these ones here around the outside, it's going to return what's this, 1. So mget, and then we're passing in x1 and y1, and then the flag. So okay, so this is where we decide, this is where we determine whether it's solid or not. So these dots here are the flags for each sprite. So it's basically 1 bit. So 1 byte, sorry, 1 byte has 8 bits, and you can set them 1 or 0. That's what this is doing. So for every sprite, we can do what we want with these. We can turn them all on, we can turn them all off. They don't mean anything until we decide to use them. So fget is the command for checking these flags. So fget, we pass in the sprite value. So let's say we passed in this value here, 001, or just 1. And then we ask it for a particular flag. So if we say sprite 1 flag 2, and it looks at this, so that's 0, 1, 2, that's this one, it will return false right now. However, if we click this, it will return true. So we can use this to give our sprites properties. So in this case, what we're going to do is give it the property of being solid or not. So we'll use sprite flag 0 to determine whether or not a block is solid. So let's go back to here. So fget command, we're using mget to get which sprite we're looking at. So mget is looking on the tile map, and in the case of a solid one, it's going to be returning one of these on the outside edges. So that'll be returning 1. So that's giving us a sprite value, and then the actual flag that we're looking for is this one, 0. And then we want to say, and I'm just going to copy these because we're going to be typing this a lot. So the next one is going to be x1 and y2. And then the one after that is going to be x2, y1. And then the last one is going to be x2 and x2. And if any of those return true, then we're going to return true. Else we return false. End. Let's just run that to see what errors I've done. Oh, no errors. Okay. Usually when I do any kind of if statements in Pico, I get at least one error. So, I mean, how many if statements do we do here and we didn't get a single error? I just mean a syntax error. I'm not saying the code's going to work, but we'll get there. So now what we can do is, let's go to here and we'll just wrap this part in its own little if statement. So say if collide, which way we're going there, left is equal to true, then do this. End. So let's just run that and see if it works. It does not work. So let me try and figure out what I did wrong there. Oh, well, sorry. One thing that we definitely did wrong is we never passed in the player. Okay, so at least it's doing something now. Like we can't walk left anymore. Back to the debugging. But you know what? This should be a false. Because right now we're saying if the block next to it is solid, then walk, and that's the wrong way around. So let's try one more time. There we go. Okay. So now when he hits a solid block, he won't walk past it. She won't walk past it. But obviously these ways we can walk off because we haven't done anything. So let's do the same for these. Just copy this. And then we need to change the value that we are checking. So in this case, it's going to be right. In this case, it's going to be up. And in this case, it's going to be down. And then let's not forget our ends. I think we might have got something a little mixed up in our collider detection. Okay, yeah, I've got this completely wrong here. So this needs to be x plus 8, or y plus 8, sorry. And then this wants to be x plus 8 minus 3, and then this one just wants to be x plus 8. Let's try that again. Okay, now we can move again. And hopefully it won't walk through the floor. There we go. She won't walk through the floor. Okay. So last thing we'll do in this video is we'll make it so that the player can walk between the two or between different rooms. So the way we're going to do that is we'll do a check at the end of update to see where the player is. And if the player has moved, how did we move before? We had map X and map. Okay, right. So what we'll do is we'll do a check at the end. And if the player has moved outside of the screen, then we move to the next map. So if player.x is greater than 128, then mapx plus equals 1. So let's just test. Oh, of course. It's an if statement, so of course I'm going to forget to write parts of it. End. So let's just test that. The player's going to be in the wrong place, but the map might work. Okay, yep. So what we need to immediately do before we redraw the map, or before we get to the next update, is move the player to the other side of the screen. Because what happened there was the player was already at the far side of the screen, so it immediately went to the next map, and then the next one, and the next one, and the next one. And obviously that's no good. So player.x equals, we'll set him to 0. So let's just test that. There we go. Although we're going to have to adjust our code for getting from the map, because right now we're checking the first screen. That's the word I'm looking for. Right now we're checking the first screen. So when we move to the next screen, the collider is still checking the first screen. So what we need to do there is, if we go into collider, this part here, we need to factor in the current map screen that we're on. So how best way to do this? Let's create a local value here for now. It's not the most efficient way of doing it. We're going to call this mx, and it's going to equal mapx times 16, and then local my is going to equal map y times 16. And then basically all of these want mx adding to them. Well, actually, we'll move it up here and we'll just do it when we set the values in the first place. Plus mx plus my plus mx plus my. Okay, that part still works. There we go. And now we're colliding against the right screen. And it won't work if we go down here because we haven't done a downwards one or an upwards one yet. So let's just do that, and I think that will be it for this video. So, now we're not going to have any diagonal ones, so what we can do here is we can make it else if. So else if player.x is less than 0, I mean that can definitely be an else if, because the player definitely can't be greater than 128 and less than 0. Then, and then we'll just copy it, well no, actually we'll just type it. We'll stop being lazy. Player.x equals 128, no, not 128, 120, because if we give him 128, because we're drawing from the left-hand side of the sprite, then he would be off the edge of the screen. So it wants to be 120, that's 8 pixels in, and then map x minus equals 1. And the way we've drawn our levels, the player's never going to be able to walk off the edge of the map because we've got solid walls all the way around the outside edge. And then else if player.y, and we can do else if here, let's just, is greater than 128. We can do else if here because the player, well, it's up to you whether you did it differently, but I'm going to leave it like this because I'm never going to have doors in the corner. So the player's never going to be able to walk off screen both left and like to the side and down at the same time. So he's only going to be ever going to be able to get off screen either up, down, left or right, but he's never going to be able to go off diagonally because I'm not going to put doors in the corner. If you were going to put doors in the corner, then you wouldn't be able to do else if here. You'd need to be able to check y and x separately. Player.y equals 0. Map y plus equals 1, and then finally else if player.y less than 0, then player.y equals 120. Let's tab that out, and then map y minus equals 1. End. And of course there is a syntax error. There is always a syntax error. In this case, I'm not entirely sure what it was. So let's test that. Let's try and walk through a few rooms. Okay, first problem, because I typoed Plato. There we go. Okay, so that's left and right we know works. And that's down, and up is broken. What's wrong with up? Because I typoed map y. My errors in Pico are 98% typos. There we go. So it's up, down, left, right. The movement's a bit janky, but we can smooth things out later. But yeah, we can now move through the entire map thing that we built in the last video. And we can't walk through any walls. And it's good. So what we can do in the next video is add traps. So, well, you know what, let's do it in this video because it's not going to take much. Or at least, we won't do the full death state, but we'll do a means of detecting traps. So if we just go to here and we can add another one of these. Else if D is equal to center, then let's just copy all this. There we go. X plus 2, Y minus 3. That one wants to stay as it is. This one wants to also be minus 3. And then for center, we want to have a slightly different check. We want to be checking for something else. So what we'll do is we'll pass in the flag that we want to check so that we don't have to write loads of random code. So let's just pass in flag there. And then we want to change these zeros to flag. And then if we go back to here and where we call, or is it up here? Where we call the command, we now need to give it which flag we want. So let's just do that. So that shouldn't change anything. That should all still work the same way it did. So now what we can do is, let's go to our sprite editor, and just down here we'll draw some spikes of some kind. There's only so much you can do for spikes in Pico-8, but I will do my best. My best wasn't good enough. Let's just delete these. There, we're going to go with that. Okay, so let's draw a couple of spikes. I mean, obviously, for a top-down game like this, you wouldn't draw spikes like this, but it'll do. And then let's use flag 2. So what we can do down here is we can say, that's where we're going to put it. We'll do it just before the map check. If, what was it, collide, and then want to pass in player and center, and then flag 1, then, and what we need now is some way of telling that the player has died, because we're not going to program an entire death state for now. So what we'll do is we'll add a bool to the init function, which we'll call died, I guess, false. And then in here we'll say died equals true, and then we'll use that in draw. After everything else is done, we'll say if died is equal to true, then print, and we'll go with, I don't know, 10 no, we need the text first. Player has died. 1010, and then we need a color, which I'm just going to use 7. And of course, I forgot to put an end or a then or whatever it is with if statements. I'm physically incapable of writing an if statement without doing an error. And I did actually forget an end there, so I wrote 2 thens then. Okay, well, what's wrong with that one then? Oh, random bracket. Okay, try that again. So we should die. There we go, player has died. I mean, he's not died, he's still walking because we haven't done anything to, like, we haven't given it a kill state of any kind. But as you can see, it detects that we walked into something that we flagged as number 2. And you could flag that for anything. You could have, if you had underwater levels, you could flag tiles as something. You could make a water level like that or something, and then I know one of these is blue there, and you could flag it appropriately with the blue one. It doesn't really matter which color it is, but you could flag it with the blue one, and then if the player is in there, is on that tile, you, like, I don't know, take his oxygen down or something. So it's just an example of the things you can do. So that is the end of this video. We've got a little character wobbling around on the screen. She's wearing a lovely pink blouse, and if she walks into spikes, she dies, kind of. And we can move around the map and not walk through walls, which is always handy in a game. Unless you're a ghost. Maybe you want to walk through walls. So that's the end of this video, and as always, at the end of my video, I like to thank all my patrons. You guys are amazing, as always, and special thanks to the top tier supporters, Julio Montero, Reg Reed, Michael Gulak, and Dave Maldine. You guys are amazing. Thanks to everyone in the Discord, and thank you for watching. Hope you enjoyed this, and we will be back next week, hopefully, or later this week, depending on when the video comes out, with a 7 Days to Die video. Thanks for watching, and bye-bye.